All right, so for this section, we're going to go over a couple of things. One of them is systems of equations, and then we can convert a system of equations into a matrix, and then multiple of these are called matrices. So a single matrix or multiple matrices, and then we're going to solve these systems of equations using Gauss-Jordan elimination. So first of all, what is a matrix? Or what is a system of equations? So a system of equations for our intents and purposes is going to be how two lines interact on the same coordinate plane. So how do two lines interact on the same coordinate plane? All right, so if this is my system, so I've got a negative 9x plus a 6y equals 9, and I got a 5x minus a 6y equals 3. Notice that each of these exponents is a 1. And so since the largest exponent you're working with is a 1, that means these are lines. And remember in math, all lines are straight. Okay? In math, all lines are straight. So we have three options. Either, if this is my coordinate plane, either I can graph two lines and say, look, they intersect and they share one point, which means there is an xy coordinate that will make both of these true. Okay, there's an xy coordinate that will make both of these true. So that's one option. Another option is that these two things are parallel. Okay, so do they share a point? No, which means it is impossible to find a point that will make both of these true. So in this case, your solution is x comma y, and you're going to tell me the coordinate that works. In this case, you're going to find out that there is no solution. So your solution is the empty set. And in the final case, what happens if I draw a line, but then there's another line on top of it? Okay, so you would see two separate equations, but when you graph it, it graphs the same line. Well, in this case, there's an infinite number of solutions. So what we're going to do is we're going to produce a formula that will tell us how to find, because there's an infinite number of xy coordinates that are shared. So we're going to produce a formula that will give me a way to identify all the coordinates. Okay, so what we're going to do is hold a variable arbitrary. So I'm either going to hold x arbitrary or I'm going to hold y arbitrary. So first of all, when we start switching these things from systems into matrices, you need to know that this is extremely foundational. And so for the purpose of two linear equations, I would never use matrices to solve them. But this is also a gateway course into upper level math, which means we're showing you what you're headed towards. Okay, so what I'm going to do is I'm going to solve this the traditional way. And then I'm going to show you how to convert it into a matrix, and then we're going to solve it using Gauss-Jordan elimination. So, first of all, I would like to kill a variable. So if I work vertically, negative 9x's plus 5x's is negative 4x's. So my x's are still there. That didn't help. So let's work vertically this way. Now I've got 6y's minus 6y's. Okay, my y's are gone. So that makes me happy. So I'm going to go ahead and say let's work vertically. So negative 9x's plus 5x's is negative 4x's. And then these just disappeared, which makes me happy because that's going to equal 12. And now I can divide both sides by negative 4. And I find out that the x coordinate that they share is negative 3. Okay, so this is not negative 3, but this is just my little picture for a representation. My x coordinate that these two things share is negative 3. So, since they share the point, then I can go back into either the top equation or the bottom equation, and I can figure out what y is. I know what x is, so let's slap it in one of those two and figure out what y is. It does not matter which equation you grab. So I'm going to use the bottom equation simply because it looks a little bit simpler. And then I'm going to solve for y. So 5 times negative 3 is negative 15. And then I'm going to add 15 to both sides. So I end up with a negative 6y equals an 18. Divide both sides by negative 6. So y is also negative 3, which means if I were to graph these two lines, I know beyond the shadow of a doubt that they share one point, and that one point is negative 3, negative 3. Okay, so your x is first and your y is second. So that's how we would solve a traditional system of equations. What we're going to do is set up a few matrices, and then we're going to dive in and start solving. So what I have right now is, notice I've got an x column, a y column, an equals, and an answer. Okay, so that's very important. Math people are lazy, but in order for us to be lazy, we've got to be really organized. So I've got my x's, my y's, my equals, and my numbers. So I'm going to translate that into a matrix. So I'm going to use a tall, hard bracket, and I'm simply going to write the coefficients. So I've got a negative 9, a 6, and a 9. And then I've got a 5, a negative 6, and a 3. And then close that with a hard bracket. Okay, so notice all I did was take the x's, so negative 9 and 5. Then I took the y's, so 6 and negative 6. And then I took a 9 and a 3. Now, what you don't realize yet is that as a math person, I see this as an x column, a y column, and a z column. So I need to somehow communicate to you, or to me, that these are answers. So I'm going to draw a vertical line where those equal signs are. So now all of a sudden my brain says, oh, okay, so this is x's, y's, and these are the answers. Okay, so this just represents your equals. So this is called an augmented matrix because it contains the answers. So an augmented matrix contains your answers. Okay, so I'm going to show you what our goal is, and then I'm going to give you a strategy. Okay, so this is my augmented matrix. My goal is to get to a 1, 0, 0, 1, and then I'm going to get a number here, and I'm going to get a number here. So I'm going to do a whole bunch of trash to this matrix, and I'm going to get this matrix. So what does that tell me? So if this is my x column, and if this is my y column, and if these are my answers, so let's cover this row up for a second. That means I have a single x value, and I know what it is. Okay, on this row, I have a single y value, and I know what it is. So what we're going to find out, because I've already solved this, I already know what the answer is. What this is going to end up looking like when all is said and done is I'm going to have a 1, 0, 0, 1, and this is going to be negative 3, and this is going to be negative 3. So that tells me my x coordinate is negative 3, and this tells me my y coordinate is negative 3. Okay, so I'm going to tell you the strategy that we're going to use. I'm going to make this be a 1, and I'm going to make a U shape. This is going to be a 1. This is going to be 0. This is going to be a 1. This is going to be 0. So that's the order that I'm attacking in. Okay, so I'm going to make this a 1, this is 0, this a 1, this is 0. You're like, wait, it already is. No, it's not, because I'm starting with this. So this I'm going to turn into a 1. Once that's done, I'm going to turn this into a 0. Once that's done, I'm going to turn this into a 1. Once that's done, I'm going to turn this into a 0. And magically, these are going to turn into negative 3s. Okay, so how do I change into 1s? To get a 1, you're going to you multiply by inverses or by reciprocals. Okay, so you're actually going to divide. But in matrix world, we don't divide, we multiply by the reciprocal. Okay, so multiply by the reciprocal. Okay, to get a 0, we're going to add or subtract rows. Okay, so to get a 1, I'm going to end up dividing the row, which actually the way I'm going to write it is multiplying by the reciprocal. To get a 0, I'm going to add or subtract rows together, kind of like I did over here. When I added these rows together, I got a negative 4. When I added these, it zeroed out. So I'm going to be looking for a 0. So here's how we're going to morph this thing. Are you ready? All right, so what is my goal? I need to get this -9 and turn it into a 1. So I am going to rewrite very neatly. And if you are a scribbly writer, you might want to turn your paper sideways and use these built-in columns to keep your stuff neat. Otherwise, you're going to end up crying softly in a pillow. All right, so I've got a -9, a 6, and a 9. And then I've got a 5, a -6, and a 3. Okay? So if my goal is to get this number to turn into a 1, well, what do I divide -9 by to get 1? I divide it by -9. Divide it by itself. So remember, this is just an equation. This is -9x plus 6y equals 9. So as long as I do it to the entire equation, I can do it. So what I'm going to do is make a little arrow with a note as far as what I'm doing. So I'm going to take -1/9 times row 1, which is the same thing as dividing by -9. Okay? Multiplying by -1/9 is the same as dividing by -9. So this just helps me backtrack in case I screw up somewhere. So notice that row 2 is not changing. I didn't note anything about row 2, so I'm just going to recopy row 2. Okay, and now we're going to end up in fraction world, but it's okay, we can do this. So in -9 times -1/9 is 1. Okay, a 6 times -1/9 is going to be -2/3. So that would be a -6/9. Reduce it to a -2/3. And then 9 times a -1/9 is -1. So I got my 1. So remember, what's my order? I'm going to get this to be a 1, this to be a 0, then this to be a 1, and this to be a 0. Okay, so this is going to be a little bit longer video because I'm going to finish this example. So I've got my 1. Now he needs to be a 5. So just look at this column. If I'm going to add or subtract rows together, if this is a 5, I need this to be a -5. Okay, so now pay attention very carefully. I'm going to write it down first and then I'm going to explain. Okay, because I am adding or subtracting, the way I write it is extremely important. So whatever I write last is where my answer goes. Okay, so I know I want my answer to go in row 2. How do I know that? Because I want to try to change row 2 into this being a 0. So what do I need this 1 to turn into? I need that 1 to be a -5. So I'm going to take -5 times row 1. So -5 times row 1. And then I'm going to add that to row 2. Now, here's the tricky part. You're not supposed to change row 1 except for in your head. You're not supposed to change row 1 except for in your head. But what you will see change in the matrix is row 2. So let me go ahead and rewrite row 1. So I've got a 1, a -2/3, and a -1. And now what I'm going to do on a little piece of scratch paper is show you what I'm doing. Okay, so here's my scratch paper. What I'm taking is -5 times everything in row 1. Okay, so -5 times 1 is -5. -5 times -2/3 is 10/3. And then -1 times -5 is 5. Okay, so I took -5 times row 1. Now I'm supposed to add it to row 2. So what is row 2? 5, -6, and 3. So what I'm going to do is add these together and put my answer in row 2. I'm going to add these together and put my answer in row 2. I'm going to add these together and put my answer in row 2. So this part is supposed to be done in your head. And if you get to linear algebra, it will be done in your head. But for right now, we're still learning. So what did I do? I'm going to do a -5 times 1 is -5. Plus 5 is 0. So -5 plus 5 is 0. So here, I've got a 10/3, so negative 5 times negative 2/3 is 10/3. So 10/3 plus negative 6, that's going to be 18/3. Okay, so 10/3 minus 18/3 is going to be what? Negative 8/3. Okay, negative 8/3. So this becomes a negative 8/3. So all I did was add this in my head. And then what's 5 and 3? 5 and 3 is 8. Okay? So I know that was slightly confusing. When you write an addition or subtraction problem, your answer will go wherever you wrote last. Whatever you write first is supposed to be done in your head. So what I would have done, if I was used to this, is I would say negative 5 times 1 is negative 5. Plus 5 is 0. Okay? Negative 5 times negative 2/3 is negative 10/3. Negative 10/3 minus 18/3, which is negative 6. Okay? 10/3 minus 18/3 is going to be negative 8/3. And then negative 5 times negative 1 is 5. 5 plus 3 is 8. So I've just got my little scratch paper going until you understand what's going on. So what have I done so far? I've got my 1, my 0. This needs to be a 1. So how do I change that into a 1? I'm going to multiply by the reciprocal. Okay, which is, so since I'm not adding or subtracting, I'm just going to take negative 3/8 times row 1. Row 2, good heavens. Okay, negative 3/8 times row 2. So all I did was flip this, because if I multiply by the reciprocal, I get a 1. So this is a 1, this is a 0. I'm making this a 1 now. And I don't need any addition subtraction to do that. So my top row is not changing. Okay, so what is negative 3/8 times 0? It's 0. What is negative 3/8 times negative 8/3? It is negative, or it's positive 24 over 24, which is 1. Okay, what is negative 3/8 times 8? It's negative 24/8, which is negative 3. So what did I tell you we were going to find? What's my bottom row already done? 0, 1, negative 3. So we got one step left. Our last step is I got to make this to be a 0. How do I make that be a 0? Well, if this was a positive 2/3, then 2/3 minus 2/3 would 0 out. Okay, so I have to be careful how I write this. I want my row 1 to change. So row 1 is going to be last. So what do I need to do to this in my head? In my head, I need this to be a positive 2/3. So I'm going to take 2/3 times row 2 in my head and add it to row 1. So again, let's get a little piece of scratch paper going. So row 1 is going to change on my paper, but for right now it needs to be a 1, a negative 2/3, and a 1/3. Nope, a negative 1. Good heavens to Betsy. Changing the whole problem. And this is a 0, 1, negative 3. Okay. So here's what I've got so far. I'm sorry, there's construction going on in the background. Okay, so what we have is I'm going to take negative 2/3 times row 2. Okay, so what is negative 2/3 times 0? 1, negative 2/3, and negative 1. Okay, so negative 2/3 times 0 is 0. Positive 2/3. Positive 2/3. Okay, 2/3 times 0 is 0. 2/3 times 1 is 2/3. 2/3 times negative 3. What is 2/3 times negative 3? It's going to be negative 2. Okay, so here's what I've got. I am now going to add these and put my answers in row 1. So I've already filled this. No, I haven't filled it out. All right, so row 2 on paper is not supposed to change because row 1 is what I wrote last, so he's going to change. So come back over here. What is 0 plus 1? It's 1. What is 2/3 minus 2/3? It is 0. What is negative 2 and negative 1? it is -3. So, I hope you can hear me. Okay, so what we've got is, I told you this is what we were going to produce. So this is what we worked on, and that's what we got for an answer. So you have successfully solved this system of equations using Gauss-Jordan elimination. So I'm going to do a few more examples in the second video.